Welcome back everyone. Today's video will be about radioactivity, my radioactive minerals and radioactive stuff. I have two Geiger counters right here and all of these radioactive materials and a UV lamp. These two are Kugelfischer SE500 Geiger counters, one with an SE8B pancake probe and the other one equipped with a probe for beta radiation. You can already hear the Geiger counters clicking in the background. What we have here is a really old petroleum lantern mantle. It contains thorium nitrate and thorium is radioactive. Stored in this metal pipe I use for radiation shielding. A second one of these is stored in a plastic bag. Here you can have a look at what this identical lantern mantle looks like. It actually looks pretty harmless. Let's hold it next to the beta radiation probe. The needle goes up all the way to 5 millirads an hour. Because the second lantern mantle is only encased in a paper bag, the needle should max out even more because the paper proves to be less resistant to radiation. But it turned out that the needle just moved barely higher. Therefore we decided to sandwich the probe between both of the mantles. This time the Geiger counter went up even more. Because we used two mantles, the radiation also seemed to double all the way up to 10 millirads an hour. If a more sensitive probe is used on the other hand, you will be able to see the needle max out even more. We are first going to measure it with the aluminum shielding. The needle moved up to 2.5 millirads an hour. Without the shielding, the scale got maxed out. Even the second scale got maxed out at 50 millirads an hour. Let's see if it makes a big difference if we use both of the lantern mantles. This sadly didn't work. The needle also went up to 50. We've also got some wick welding rods containing 2% thorium oxide. With the beta radiation probe, nearly no difference was observable. The more sensitive probe, on the other hand, seemed to detect some more radiation. A small difference became visible. But sadly, the welding rods seem to be nothing when compared to those. Now we've got some autunite. It's some uranium-containing rock which fluoresces under UV light. We will directly go for the sensitive probe. Unfortunately, this rock isn't really that radioactive, but you can see a small difference on the scale, and it's still cool to have it. What's most interesting is that plain potassium carbonate is also radioactive. This is due to the potassium content containing at least 0.01% of potassium-40, which is a radioactive potassium isotope. Potassium-40 is also the reason why bananas are slightly radioactive. I also have two lead picks. Inside of this one is uranium glass and the other one is empty. Under UV light, uranium glass also fluoresces. When holding the beta radiation probe next to it, nearly no change on the scale of the Geiger counter becomes observable. When the more sensitive probe is used, a nearly negligible difference in radiation compared to background radiation can be measured. Uranium glass contains only a small amount of uranium, therefore it isn't that radioactive. Let me put that back into the lead pick. Have a look at the bigger lead container. This one has a thicker lead wall and it's also quite heavy. It's currently not in use and there's only a radioactive sticker contained in it. Now we are going to have a look at what all of you probably waited for. Elemental uranium. This sample contains 0.016 grams of metallic uranium. Metallic uranium is normally quite shiny, but this sample has been exposed to air and therefore a small oxide layer is on the surface of the uranium. When we hold the uranium onto the probe, you can immediately see a big change appear. But with the more insensitive probe, you can also see a change. I accidentally made a small scratch into the probe. By the way, you should never touch the metallic uranium barehanded because uranium metal is toxic. Besides being toxic, it's obviously also radioactive, and when you get it into your body, it won't be good for you. Just don't do it. For fun, the samples were all piled up in one big pile and the probes were held next to it. But wait, we've got even more exciting stuff. This is a case full of dosimeters. This is what one of these dosimeters looks like. What are these? Well, you charge them up, you set them to 0 and you can put them into your pocket. And then you are able to read what dose of radiation you got. When you look through them, you can see a scale, but I'll have to try a few other ones to get that on camera because it's pretty hard to see with your bare eye too. A fresh one with a better scale was taken out of the box. It's out of focus, but you can still see a few numbers and a line in the middle. Before use, this line has to be set to 0 by using one of the buttons on this handheld device. I even got a good in-focus shot of the scale. You see the moving line, you see numbers from 0 to 50 and you see the word Röntgen. This is because this stuff measures your radiation dose in Röntgens. There are two different types of pan dosimeters in this case. One is from 0 to 50 and one is from 0 to 500 Röntgens. Now you can have a look through one of the 0 to 500 things. Let me quickly put everything back into the box. Well, this was it for this video. I hope you enjoyed it. If you did, make sure to drop me one of these and consider subscribing to my channel for more stuff like this in the future. I wish all of you a nice day. Until next time.